So this question comes from section 5.2. It's question number 8. And it says that you have a telescoping series given below. And it says to write the expressions for the first 4 terms of the sequence of partial sums as sub m. And it says to leave your answers in unsimplified sums of fractions. So what you would do is you would start by putting in, for the first 4 terms, you're going to use 1, 2, 3, and 4. And so what we would do here is we would say seven over the cubic root, and plugging in 1 here, we would get 1 plus 1, or 2. And then we would say 7, and plugging in 1 here, we would get the cubic root of 1, which is 1. Now, again, we don't have to simplify right now. We're going to see what's happening. And so I'd write this for s sub 1. And I would continue that, and you'll see that these filled in for us using 2 for n, using 3 for n, and then using 4 for n. So now let's continue in the question. So it says, based on this data above, give the formula for the mth term, s sub m. So we're going to use this these 4 terms together, and we're going to look at them. But I'm also going to write out some of the last terms. So, and this is using m. So I'm going to say, all right, what would be, and I'm just going to write the individual terms. So not the sum of them, but just the individual terms. So I'm going to say, what would the term a sub n minus 2, so this would be one of the last terms, and so that would be 7 over the cubic root, and in place of n, I'm going to put in m minus 2, and then it will be plus 1. And then, and here, maybe I can do this a little differently. And it will be 7 over the cubic root of n. So in place of n, I'm putting in m minus 2. And so here, I'm going to get, for the denominator, the cubic root of m, and that will be minus 1. And then I'll do the second to last term. Well, the second to last term would be m minus 1. And so in place of n, I'm going to put n minus 1. And, oops, wrong symbol here. This should be plus 1. And here, m minus 1. So then when I combine this, negative 1 plus 1, it's going to be 0. And then I'll do the last term. So let's call that a sub m. So that would be 7 over the cubic root of n plus 1 minus 7 over the cubic root of n. So I'm going to replace the n with m. All right, so now I'm going to use some different color markers here, and we're going to cross off when we're looking at the partial sum s sub n, which is the next question. I've got now the first 4 terms up here, and then I've got the last 3 down here. So let's erase this part, and then let's cross off, because when we're taking the sum, we have to add these together. So let's see, the 7 over the cubic root of 2 here, and this would be minus, so that's going to zero out. And then we've got 7 over the cubic root of 3 minus 7 over the cubic root of 3. So this one also will cancel each other out. And then we've got the 7 over the cubic root of 4 minus 7 over the cubic root of 4. And so we know that, so we can see the pattern that's emerging. The next term would have 7 over the cubic root of 5, and that would cancel out over here. And so let's see what's happening down here. We've got 7 over the cubic root of m minus 1, and we've got minus, so those cancel out. Then we have 7 over the cubic root of m, and that canceled out here. So we would know the pattern that emerges. This one would have been in the previous one, the previous term. So we can see the pattern. And so what is left? Let's highlight what is left. We've got this part of the last term, and we've got this part of the first term. And so when you have a series that the middle terms will cancel each other out, and you're basically left with the first term and the last term, that's a telescoping series. So what I highlighted here will be what we will put for our sum. So let's write that down below. Let me give myself some more paper. So S sub m would equal a 7 over the cubic root of m plus 1 minus 7, because 7 over the cubic root of 1 would just be 7 over 1, and so 7 over 1 is 7. So that is my next part. And so now we need to see where this, if this converges to a number. So to find that, we will take the limit as m, oops, I wrote n, approaches infinity. So that's what we see in the last question. Is compute the limit as m approaches infinity of the m partial sum. So we are going to find the limit as m goes to infinity of 7 over the cubic root of m plus 1 minus 7. Now, this part here has no variables in it, so this is just negative 7. And if we look at this part here, 7 over, as in the denominator here will get larger and larger, it will go to 0. So we're going to end up with 0 minus 7, which is negative 7. And so that is the limit here. And so that is the limit of S sub n. So that is how to do that question.